Hey everyone, welcome to today's Astronomy Daily. I'm Anna.
And I'm Avery. It's Friday, August 21st, Series 5, Episode 173.
And today we've actually got a bit of a case closed story to lead with. Remember that SpaceX rocket stage that slammed into the moon a couple weeks back?
The one everybody was speculating about because nobody could say exactly where it hit.
That one. NASA's finally got the pictures. We know exactly where, exactly how big, and it turns out an international team basically built a forensic investigation around it.
Then some less happy space news. The rescue mission for NASA's Swift telescope has officially failed.
It has. And stick with us, because story number 3 connects right back to that one in a pretty ironic way. Plus, a fresh satellite launch out of New Zealand overnight.
And tonight's sky has a proper deep sky target if you've got a telescope handy.
Let's get into it.
Okay, so back up for people who missed it. What actually happened here?
On August 5th, a spent SpaceX Falcon 9 upper stage, basically dead hardware left over from a launch no longer under control, struck the moon's surface. This kind of thing happens more than people realize. There's a fair bit of leftover rocket hardware drifting around out there, and every so often, the orbits catch up with it and something comes down.
So this wasn't a SpaceX aimed for the moon story.
Not at all. It's an uncontrolled impact. What made it interesting was what happened next. Astronomers around the world had been tracking this stage for a while and had a rough prediction of where and when it would hit. So this became a genuine race to go photograph the aftermath before anyone even knew exactly what they'd find.
And they found it.
They found it. NASA's Center for Near-Earth Object Studies, that's the Planetary Defense Program, took tracking data from independent astronomers and refined the impact prediction, then handed that off to the international partners flying spacecraft around the moon. First on the scene, so to speak, was South Korea's Danuri, the Korea Pathfinder lunar orbiter, which used its LUDI camera to image the impact site within hours and nailed the predicted location to within about 0.6 of a mile.
That's a genuinely tight prediction for something falling out of the sky uncontrolled.
It really is. Danuri then passed its refined coordinates over to the Lunar Reconnaissance Orbiter team, and LRO's narrow-angle camera got its own images on August 11th and 12th. Those are the ones NASA released this week with the full analysis.
So what does the crater actually look like?
It's about 60 feet wide and less than 10 feet deep. Modest by lunar impact standards, this isn't a dramatic scar you'd spot from Earth. But what's genuinely useful about it are the rays, these streaks of ejected material radiating out from the crater. LRO caught both darker rays and brighter rays, and each one tells you something different.
How so?
The darker streaks are made of surface material that's already been sitting exposed to solar wind and cosmic rays for a long time, what's called space weathering. And that was dug up from about 1.5 feet down. The brighter streaks are fresh material, excavated from even deeper, that hasn't been weathered at all yet. So you're essentially getting a cross-section of the lunar soil at 2 different depths, handed to you for free by the impact.
A rocket stage as an accidental science instrument.
That's honestly the most useful way to think about it. It's not a mission, nobody planned this experiment, but planetary scientists get real value out of studying these fresh, precisely dated impacts because they help calibrate how quickly the moon's surface weathers over time, which matters for dating other craters we can't otherwise put a clock on.
Coordinates for the record.
19.4759 degrees north, 266.7138 east, at an elevation of about 511 meters. So next time you're looking at a full lunar map, that's roughly the spot where a piece of Falcon 9 is now permanently part of the moon.
Tiny, uninvited addition to the lunar surface.
It's not going anywhere. All right, this next one's a tougher story. An official update to a story we've been following for some weeks now, and it's not a happy ending. NASA's Swift Observatory, a telescope that's been watching gamma-ray bursts and other high-energy events since 2004, has been slowly losing altitude, faster than expected because of increased solar activity puffing up the upper atmosphere and adding extra drag.
So it's literally falling.
It's literally falling, and without a rescue, it's going to burn up in an uncontrolled reentry sometime before the end of this year. So NASA took a bit of a gamble. They signed a $30 million contract with an Arizona company called Catalyst Space Technologies, to build a dedicated rescue spacecraft called Link and try to dock with Swift and boost it back to a safer orbit.
That's an extremely tight turnaround for building a spacecraft.
Under a year, designed to launch. Link actually got off the ground on July 3rd, riding a Northrop Grumman Pegasus XL rocket. And for about 3 weeks, things were tracking toward an actual rendezvous attempt.
And then?
And then Link itself started spinning uncontrollably, an attitude control failure on the rescue spacecraft, not on Swift. NASA made the failure official on August 19th. Swift's fate is now sealed. Uncontrolled reentry sometime before year's end. No more boosts coming.
Is that just it then? Mission over, nothing learned?
Not quite. Link is apparently still going to attempt a close approach to Swift, even without being able to dock and boost it, just to gather proximity operations data for whatever the next rescue attempt looks like. And NASA Administrator Jared Isaacman put it about as honestly as you can. This is not the outcome we were working toward, but it does not change why this mission was worth attempting.
Which is a very diplomatic way of saying, we tried something hard and it didn't work, but we needed to try.
Exactly that. Satellite servicing and rescue missions are still a genuinely new capability. Nobody's got this down to a routine yet. Every attempt, successful or not, is teaching people how to actually do it.
Small silver lining for a telescope that's about to become a shooting star.
A very expensive, very short-lived one.
Okay, you said this one connects back to Swift. How?
Because Swift's X-ray instrument is actually part of the data behind it. One last bit of science out of that observatory before it goes. There's a blazar, that's a supermassive black hole blasting out a jet of plasma pointed almost directly at us, called PKS 2233148. A team led by Silke Britson at the Max Planck Institute for Radio Astronomy has been watching its jet using 3 different instruments together. The Very Long Baseline Array here on Earth for radio, the Fermi Telescope for gamma rays, and Swift for X-rays.
3 instruments stakeout.
Right, and combining all 3 is what let them catch something odd. The jet's motion changed in a way that doesn't match a normal blazar. It made a sudden, unexpected deviation, almost like something invisible gave it a nudge partway along its path.
And something invisible is doing a lot of work in that sentence.
It is, because the team's explanation is that an unseen clump of dark matter sitting between us and the jet is gravitationally lensing it, bending and magnifying the light of the jet, just like the way a giant galaxy cluster can lens a background galaxy, just on a much smaller, much harder to catch scale.
Why does that matter beyond cool? Dark matter did a thing.
Because we still don't know what dark matter actually is, and one of the best tools we've got for finding out is looking for its substructure, clumps of it, through exactly this kind of subtle lensing signature. If this holds up, it's one of the first times anyone's caught a dark matter clump lensing a blazar jet specifically. And there's a bonus angle. Blazars are suspected sources of high-energy cosmic neutrinos, the ghost particles that barely interact with anything. A confirmed lensing event like this could help prove blazars really are where some of those neutrinos come from.
Britson have anything to say about it?
Her quote was, "We are very happy to have discovered as yet undetected phenomena in the jet, as well as in the gamma-ray light curve," published in monthly notices of the Royal Astronomical Society back on July 31st.
So even mid-collapse, Swift's still out here doing useful science.
Going out on a high note, at least. Next, a quick one to close out the news. Rocket Lab had a launch overnight from their pad in New Zealand.
What'd they send up?
A satellite called Susanoo-2 for the Tokyo-based company IQPS. That's their 9th satellite launched by Rocket Lab now. It's a synthetic aperture radar satellite, meaning it images the ground using radar instead of visible light, so it can see straight through cloud cover and works just as well at night as during the day.
Handy for a company building out a whole constellation of these, I'd guess.
Exactly. This is satellite number 9 toward a planned constellation of 36, all aimed at giving customers near real-time, high-resolution radar imagery of pretty much anywhere on Earth. The mission was nicknamed the Lightning God Defends, lifted off on an Electron rocket, just 59 feet tall, and dropped Susanoo-2 into low Earth orbit about 357 miles up, roughly 50 minutes after liftoff.
Rocket Lab's keeping up a pretty relentless launch pace this year.
This was their 14th flight of 2026 alone and 93rd overall for the Electron rocket. They're closing in on their own record with plenty of year left to go.
No signs of slowing down.
None at all.
All right, before we go, what should people actually go look at tonight?
If you've got a telescope, even a modest one, 4 inches or so, pointed at the Ring Nebula tonight. Look straight up after dark for Vega, the brilliant star practically overhead, and just below it you'll spot a neat little parallelogram of stars marking the constellation Lyra. The Ring Nebula, cataloged as M57, sits right inside that parallelogram.
What are we actually looking at with that one?
It's the glowing, ghostly remnant of a dying sun-like star. Through the eyepiece at decent magnification, 100 to 150 times, it looks like a small pale gray smoke ring hanging against the star field. If you've got an oxygen 3 or narrow band filter, that'll make it pop even more against the background.
And for anyone without a telescope tonight?
The moon's the easy target. It's a waxing gibbous, about 63% illuminated, nice and bright overhead through the evening. And mark your calendars for next week. A partial lunar eclipse on the 27th and 28th is going to cover a full 96% of the moon's face, about as close to total as a partial eclipse gets. We'll have full viewing details for that one as it gets closer.
A teaser and a homework assignment in one.
That's the job. And that's it for today's episode. Series 5, episode 173 in the books, so to speak.
Quick recap. NASA and international partners pinned down exactly where a SpaceX rocket stage hit the moon, the rescue mission for NASA's Swift telescope comes up short, a black hole jet may be getting a boost from unseen dark matter, and Rocket Lab keeps its launch pace red hot with a new radar satellite for Japan.
If you enjoyed the show, the best thing you can do is tell a friend. Leave us a rating wherever you listen and follow us. Just search Astro Daily Pod on your favorite platform. Full show notes and links are always up at astronomydaily.io.
We'll be back tomorrow with the weekend wrap from across the universe. Until then,
Keep looking up.
clear skies, everyone.